So the example that we're going to look at here is a whole, this time cut up into 5 equal pieces, so fifths, and we're going to look at not just 1/5 but 2/5, just to see that it works for multiple fraction pieces. And of course it's recorded as 2/5, and let's see what we can convert this into. So following our process, first we can cut each piece just into 2 pieces as shown, and if I do it to 1 then I need to do it to each of the other pieces. And of course that would mean that I have actually made twice as many pieces. So they're not fifths anymore as shown in my green here. There's twice as many pieces, so they're now tenths. And if I have twice as many pieces through my shape, then I would have twice as many coloured in blue. So there's twice as many of those, so multiplied by 2 up the top, and I have 4/10. Now let's continue this on. This time I've got my 4/10 there, but I'm now starting to cut my shapes pieces into thirds, or cutting them 3 times. So I'll cut the next one along into 3, the next one into 3, the next and the next. And what I've done is with my fifths, I've made 3 times as many because I've cut each one 3 times. So I multiply that denominator, if you like, by 3. So there are now 15 pieces, 15ths. And as a result of cutting each piece into 3 pieces, each of my blue pieces, now there are 3 times as many. So it's 2 pieces originally, but now there are 3 slices within each. So it's 2 groups of 3, so 6. 15ths is what I've ended up with. So if we keep our 2/5 being converted into 4/10 and 6/15 as answers on the screen here, and just look back at the 2/5 as it originally appeared, we can now repeat this process yet again, and this time we're going to search for what we can convert it to if we cut each piece up 4 times. So if I cut my fifths up into 4 pieces, as shown with my green multiplier at the denominator there, it would look like this for the first piece, cutting that into 4, then cut the next piece into 4, the next, and the next. And so I'll have 4 times as many smaller pieces than I started with. So my fifths will become 20ths. And of course, because I've cut each of my light blue pieces into 4 as well, I have 4 times as many as those. So it is the 2/5 are now becoming 8 smaller 20ths. So this pattern can repeat over and over depending what we want to convert to. So I could convert my 2/5 by cutting each fifth into 5 smaller pieces, which will leave me with 5 times as many fraction type pieces, changing the fraction type to 20/5. And of course my light blue original 2/5 were cut up 5 times each, so I have 2 that are cut up by a factor of 5. So there are now 10 smaller 20/5. And of course this process repeats and repeats. So I could cut everything up by sixths. So I could cut every piece 6 times. That means there's 6 times as many, so the fraction type would change from fifths to 30ths, and there would be 6 times as many pieces of my 2/5 in light blue, becoming 12 little pieces that are 30ths, so 12 30ths. So if we return to our original diagram of our 2/5, we can see that we can convert these fractions by cutting and cutting however we please. However, we can only make multiples of 5. So in this case, we made 10ths, 15ths, 20ths, 25ths, and we could keep going on and on and on. But by the nature of only being able to cut into 2 pieces or 3 pieces or 4 pieces, you'd realise that you can't cut fifths into sixths or sevenths, or those other fraction types that are in between the multiples of 5. So this pattern is true for all fraction types. And what we can also notice is how we created these different fraction types when we're converting. So we cut everything 2 times to create tenths. So we can multiply the numerator and denominator by 2 because we ended up with 2 times the amount of pieces that we had, and the types of pieces became 2 times smaller, which of course meant we had 2 times as many. So we started with 2, twice that gives us 4, so we have 4/10. And again, we looked at cutting each piece into 3, and that would give us 3 times the amount of pieces, and it would also give us 3 times smaller for each piece, which would make them 15ths, and we would have 6 of those coloured in. And again, we can see the same effect, that when we cut up our shapes, they will multiply the amount of pieces we have, as well as multiply a smaller fraction type that we have as we go along. So this has revealed to us a rule. When we multiply the top and we multiply the bottom of any given fraction, we will keep the exact same type of fraction in terms of amount, and we'll discover an equivalent fraction that is cut up differently. Now, be careful using this. Make sure you understand it and connect it with the drawings or with the fractions themselves, as sometimes we use this rule without understanding it and causes other problems. However, this will always work.